In this video, I want to talk about tuning hyperparameters using the Azure Machine Learning Python Software Development Kit. For that, we're going to need a few resources, assuming that you already have the basics set up to have Azure Machine Learning Workspace running. For that, you need application insights, a storage account, a key vault, and a small detector alert rule, all within a resource group. So I'm going to go ahead into my Azure Machine Learning Workspace in the Designer Studio. Once my studio is loaded, I'm going to go under Authoring and click on Notebooks. In Notebooks, I already have a notebook created. If you don't have one, all you have to do is click Add Files to create a note. But I'm just going to use the folder that I already have, and I'm going to go ahead and create a compute. For my compute instance, for this example, I'm just going to give it a name. I'll give it a name of ACAML. You can name it whatever you like. And for the virtual machine size, I'm just going to do the 4-core standard DS3 version 2. I'll hit next to check my scheduling. We can configure security parameters, application options, tags, and once we're happy with the review, we can create it. Now I'll click on my notebook. I'll check out how my compute instance is doing by clicking the terminal here. As you can see, within the first line, it's recommending that we can do a git clone for a URL. So I'm going to do exactly that. I'll do git clone, and I'm going to reference this Linux Academy GitHub repository for this data scientist lab. And I'm going to copy and paste this link here and hit enter. Once we've run the git clone command with our URL, all we need to do is click this refresh button. As you can see, we have new files. And under hands-on labs, we got a few different things that I've pulled from the GitHub repository. And the first thing I need to do is authenticate. You just got to click authenticate here, and we're going to get a page for a second, and we'll authenticate. Now under this file, as you can see, there's a snippet of Python code here, about 6 lines. And all this Python code does is import Azure Machine Learning core modules. And with that, we just load the workspace from a saved configuration file. Now I could run this script manually, but with the notebook, all I gotta do is press this play button, and it's gonna run it for me. Now it's queued, and it's not gonna run until we select a kernel. At the top right, we can see there's no kernel connected. So we gotta start the Jupyter kernel. And as you can see, this is completed, and it's now ready to use. Now if we scroll down, we can create a diabetes dataset. If we were working for a medical clinic, we can run something like this. If you remember watching one of my previous videos, we talked about some regression models and classification models when using the Azure Machine Learning Designer. And we were able to use different regression algorithms and using a dataset and processing the data through different models, through different modules like normalization of data or splitting the data into a train model and into evaluation models. So instead of using the Azure Machine Learning Designer, we can just create the dataset from here with this Python script. And all you got to do, find the script that you need to use from your GitHub repository and hit run. As the script runs and processes, you can see we have full level of transparency of every process it's running every step of the way. Now that our dataset is registered, we can move on to create a training script. So the first code, we're just creating an experiment folder. Once the folder is ready, we can use this Python script and save it in the folder. This is the diabetes training module. As we can see from the body of this Python script, here are our hyperparameters and our hyperparameter values, and training different algorithm models with specified hyperparameters. So once this is completed and written the contents to this file, we can go ahead and assign the compute target by just running this Python code. In this piece of Python code, we have a cluster name. And this is a pre-generated cluster name that is not the name of the cluster that I've just created in this video. So in order to find the cluster name, in the bottom left-hand corner under Manage and Compute, I'm going to click on my compute instance, scroll down, and I can see my compute name right here. So I'll copy it, head on back to my notebooks, and replace this cluster name with the one that I have. So now that I hit run, now it says found existing cluster, and it's going to use it. Next, we move on to the hyperparameter tuning experiment. The point of running a hyperparameter tuning experiment is by having these hyperdrive functions, which tries to find the best algorithms to train our model with. If you have any experience with regression models, then you know the higher the R2 score is, the better the model is doing. And the lower the error score is, the better it's doing. And depending on what regression algorithm model you're using to train your dataset is going to determine the quality of your output. So these hyperdrive settings are here to calculate what algorithm is the most effective to use with the task we're trying to accomplish. So with that in mind, we're going to go ahead and run this cell. So now as it's running, it's creating a grid parameter sampling set with the hyperdrive parameters that we put in here. And the hyperdrive setting configurations are then set within the hyperdrive function, which is then called, when we run the experiment, it submits the configuration of the hyperdrive. So the experiment ran for 16 minutes. And basically what it did is it ran through a whole bunch of experiments, and now it gave us a return of the best, most efficient experiment that it ran. Now this is the best performance run, and it gave us the output. So now this one is going to find this best performing run. So it's going to take this output, and this code has finalized our run, which prepares it for the next one, which is the last step, which is to register the model for that best performing run to make sure next time we do this, we can use the best one every time we're running the same task. So once our code is complete, we can see here is our model that we can now, here is our registered model that we can now use to get the best performance in the future every time we redo this task. So that's all I have in this video. I'd like to thank you guys for watching.